Hi folks, in these demonstrations, we show you an example of hard water. Investigate the causes of the hardness of water and to show how hard water can be softened. These two test tubes contain water from two different sources, and we want to see how they behave in the presence of soap solutions. So we take equal amount of soap solution and pour it into each of these, okay? And now we will shake these up to see how they lather. Do you see a difference in the degree of lathering here? Definitely we can see that this test tube lathers up more readily than that one. It gives a greater degree of lathering, right? Than this one here. This one here is said to be hard water because it does not lather up as well as this one here. This poses a problem for a guy who is operating a laundromat. What you're seeing here is that equal amount of soap was used, but this one here produces more lather than that one. So the degree of lathering is an indication of how well the soap will work. So let us see how would this one achieve the same degree of lathering as this one here. We have to use more soap. Let's see if we use some more soap. Still, we're not getting the amount of lather as that one here. So as far as the laundromat guy is concerned, he has to use more and more soap to achieve the same effect. So really what is happening there, you can see, is that he has to use more and more soap to clean the clothes. And this represents a wastage of his soap. We call such type of water that is very reluctant to form a lather hard water. It is believed that the presence of certain ions in water causes it to become hard. So in this investigation here, what we'll do, we'll take equal volumes of distilled water and we'll add to that sources of magnesium ions to the first one, calcium ions to the second one, some sodium ions there, and we will leave this uncontaminated. And then we'll add equal volumes of soap to each test tube there, and then we shake and we monitor the degree of hardness by the amount of lather that is formed there. So that is what we're going to do now. We have these test tubes here with equal volumes of distilled water. So in the first one, you put some amount of magnesium ions, all right? In the second one, we'll put some source of calcium ions. The third one, we'll put a source of sodium ions. And the last one, we'll leave just like that. So we'll top it up with distilled water there to ensure you all have the same volume. To each of these, we'll add same volume of, or same number of drops of soap solution. That amount there. First one, same. Second one, same volume there. Third one, same volume there. Fourth one, distilled water. We'll now shake these up and then see the degree of lathering. That is what is it for the one that contains magnesium ions. That is it for the one that contains calcium ions. That is what it looks like for the one that had sodium ions. And this is the one without anything, distilled water. Clearly you can see that the first two test tubes were affected by the presence of magnesium and calcium ions. The third one that had sodium ions was not affected, nor the one without anything. So we can simply say that it is the presence of magnesium and calcium ions in the water that causes it to become hard. We could have done this with other ions, and you will get the same result as these here. The only thing that will give us less lathering would be the calcium and magnesium ions. So we can safely say that hardness of water is due to the presence of magnesium and calcium ions. Why does that happen? That happens because when there's either magnesium or calcium ions present in the water, or both of them, they react with the soap molecules there to form a precipitate. And this comes out as what is called soap scum. And this is a nuisance to the guy who operates the laundromat because this is deposited as a white substance on the clothes. It's a nuisance there. And also, the solid that is formed goes through the drain, and sometimes they deposit as what is called pipe scales, and gradually, the bore of the pipe becomes smaller and smaller, and it can cause blockages of the pipe. So this is what happens. The magnesium here is an ion, right? Reacts to these guys here to form a solid. So these are being deprived of washing the clothes, or forming the lather that does the cleansing process, right? Same thing happens if you have calcium here, you have this calcium stearate solid being formed here. So this is why they cause hardness of water. All they do is to bring down the soap molecules as solids, and therefore they do not perform their work well. And what happens is that for them to do that, as I said before, you have to use more and more soap to precipitate all these calcium and magnesium ions. When they're well precipitated, then you have the soap, they can continue to do their work, okay? We will now demonstrate to you how hard water can be softened. So we'll repeat the same experiment. We'll use the same volume of distilled water, and we'll add sources of magnesium, calcium, sodium, and that one will have only distilled water. But then what we'll do, we'll add a reagent or something to it that will remove these ions from the water, something that will precipitate them out, such that they do not interfere with the soap. And what we'll add is potassium carbonate. We'll first of all add equal amount of magnesium, same amount of magnesium there, calcium ions there. I want to keep everything the same. Sodium ions, same. And then we top this up with distilled water, so that all the volumes are the same. Now what we'll do is this. We'll now take a source of carbonate ions, could be sodium carbonate, potassium carbonate, and we will pour equal amount of drops into each. Tap this one up a little bit more. Immediately you can see that a white precipitate is formed in the first and second case. These precipitates are precipitates of magnesium carbonate and calcium carbonate. Effectively, what has happened there is that we remove most of the magnesium and calcium ions and precipitated them out of solutions. Now we'll see if that had any effect on the hardness of the water, or whether or not the water has been softened. So we put into each of them, now we put equal amount of soap solution. And then we compare the degree of lathering with what we obtained before. Okay. So we'll do this one first. This is one with distilled water alone. That the lathering we get there, we expected that. That with sodium ions there, nearly same as that there, no change. Now look at the degree of lathering now compared to those before. See, in the previous case, we did not get that degree of lathering. Why are we getting that now? Because we have removed the causes of the hardness of water. We have precipitated the magnesium and the calcium out of the water. And that is how hard water can be softened, one of the ways. By using something such as carbonate ions which form precipitates with the magnesium and calcium ions present there. In this final set of demonstrations, we want to investigate whether or not hard water has an effect on detergents. So we'll repeat the same experiment now. In this experiment, we'll put the same amount of magnesium ions inside there with distilled water, same amount of calcium ions inside this distilled water here, distilled water. We use sodium ions here. We just want to show that these sodium ion does not affect the water in any way. And then finally, we use distilled water to tap that up, right? Now we'll use detergent molecules, okay? See whether or not we'll get any precipitate form. So we use same amount in each. See if you get any difference in the lathering there. Okay. So now we'll shake each up. You're watching now. Shake this. Lots of lathering there. Nice lathering. Well, so we can see in each case there, the degree of lathering is the same, okay? If magnesium and calcium ions had any effect on the detergent there, you will not see this degree of lathering. So one of the advantages of using detergent instead of soap, where the water is contaminated with calcium and magnesium ions, is that the detergent is not affected in any negative way. That is it for now. We've shown you the causes of hard water, how hard water can be softened. We show you how detergent is not affected by hard water, okay? Well, thank you for listening, and I hope that was useful. Thank you so much. Bye-bye.